There are moments in space exploration when humans have to let go, not because we give up, but because distance makes us powerless. A spacecraft hits the thin edge of Mars's atmosphere. Fast, unforgiving, no second attempt. Back on Earth, a room full of engineers stare at screens as if they're watching a heart monitor. Because for the next few minutes, they cannot steer, they cannot fix it, they can only wait. And hanging over that silence is a question that has followed humanity for centuries. Did Mars ever live? Picture the scene. A rover has traveled millions of kilometers. It has survived vacuum, radiation, and the long dark between planets. Now it has reached the final test, the descent. Heat builds. Speed is violent. A parachute must open at the right moment. A shield must detach. Radar and cameras must wake up and recognize the ground. But here's the part people forget. Even if everything goes perfectly, the news arrives late. Signals take minutes to cross space. So when Earth receives the rover's data, the outcome is already history. Success or failure happened long ago, without anyone on Earth able to reach in and change it. That delay turns a landing into a kind of confession. You learn what happened after the fact, like reading a letter that can't be answered. Then the message finally arrives. Touchdown confirmed. A machine built on Earth is now sitting on another world, and suddenly, the real story begins. Mars has never been just a planet. It's been a mirror for human imagination. In the 1800s, astronomers thought they saw channels etched across the red surface. Some believed they were signs of engineering. The idea of intelligent Martians was born not from evidence, but from how badly people wanted the universe to feel populated. Later, better telescopes and better science pulled that fantasy apart. No cities, no canals, no civilization waving back at us. But the mystery didn't disappear, it evolved. Because when spacecraft finally reached Mars, they found something stranger than aliens. They found the fingerprints of water. Rock layers shaped as if they were laid down by flowing rivers. Minerals that typically form when water lingers. Landscapes carved like dried lake beds. And water changes the question. Did Mars have intelligent life? But was Mars ever suitable for life at all? This is where modern missions take a sharper aim. They don't hunt for monsters. They don't expect bones. They don't search for footprints across sand. They look for life the way life actually started on Earth. Small, simple, microbial. That means the evidence would be subtle, almost insulting in its quietness. A chemical imbalance trapped in stone. A pattern in minerals that hints something once fed there. Organic molecules preserved like whispers inside ancient rock. So the mission becomes less like a treasure hunt and more like forensic work. And then comes the next decision. Where do you land? You don't pick the most dramatic scenery. You pick the place most likely to have kept secrets safe. That's why this rover's destination matters. It lands inside an ancient impact crater, a giant wound from a long ago collision. But the crater isn't the point. The point is what happened after. At one time, a river seems to have poured into that crater. And where rivers slow down, they drop sediment. They build something that on Earth is famous for preserving history. A delta. Deltas are nature's archive. Layer after layer of mud and minerals. Tiny grains that settle, compress, and lock away a record of the environment that formed them. If Mars ever hosted microbes, a delta is one of the best places to hide their traces. But getting there isn't easy. Mars has no roads, no maps you can trust, no rescue vehicle waiting over the hill. The rover moves carefully, almost cautiously, because one bad wheel placement can end a mission that took years and billions to build. So it travels in short bursts, stops, studies the ground. During the Martian day, it drives and investigates. During the Martian night, it goes still and sends its findings home, and everything it does is shaped by the same cruel rule: time delay. Engineers can't joystick the rover around rocks. They plan a day's worth of actions, transmit them, and then wait. The rover carries out the plan alone, like an explorer who can't ask for help. Then it reports back. There's another quiet detail that makes this feel even more alien. A day on Mars is longer than a day on Earth, not by hours, by minutes. Enough to disrupt human schedules. Enough to force mission teams to live on Mars time, slowly drifting away from Earth's rhythm. As if to understand Mars, you have to borrow its clock. But the most important part of this mission isn't the camera. or the wheels, or even the laser that can zap tiny bits of rock to read their chemistry. The most important part is what it collects. Because this rover doesn't just search for answers, it stores questions. It drills into rock, extracts small cores, seals them inside clean tubes, labels them, and in some cases it places them down like breadcrumbs. Not because the rover can't analyze anything, it can, but because the kind of proof scientists want is too demanding for a rover-sized lab. The best laboratories in the solar system are still on Earth, and that leads to the next bigger mystery. If the real goal is to bring pieces of Mars home, how do you launch something off another planet? Launching from Earth is hard. Launching from another planet is something else entirely. Mars is far away, cold, dusty, unforgiving. There are no launch towers waiting, no technicians tightening bolts, no second chances if something goes wrong. Yet the plan is exactly that. One day, those sealed tubes will be collected, not by the same rover, but by another machine built for a single purpose: retrieval. It will gather the samples, place them into a small rocket, and attempt something humans have never done before. A launch from another world. The rocket won't rise on a pillar of flame like those on Earth. It will be smaller, faster, almost abrupt. Thrown upward, ignited, gone. If everything works, the container will slip into orbit around Mars, becoming a tiny, fast-moving target against the darkness. Later, another spacecraft will hunt it down. Not a planet, not a moon, but something no bigger than a basketball. Catching it won't be dramatic. No explosion, no roar, just precision, timing, silence. And if that succeeds, the samples begin a quiet 6-month journey back to Earth. But here's where the story turns uncomfortable. Because bringing pieces of another planet home isn't just an engineering challenge, it's a biological one. No one expects Martian microbes to leap out and infect cities. But science doesn't rely on hope, it relies on caution. History has already taught us what happens when worlds mix without preparation. When explorers carried unseen organisms across oceans, the results were devastating. So the question becomes unsettling. What if Mars still holds something alive? Something adapted to a world without oxygen, without warmth, without mercy? If that exists, do we isolate it forever? Do we study it behind sealed walls? Do we risk bringing it close to ourselves? And there's an even stranger thought. What if the danger isn't Mars harming us, but us harming Mars? Mars exploration isn't about abandoning home. It's about understanding how rare, fragile, and precious a living world really is. So when the rover continues its slow journey across that ancient delta, it's doing more than rolling over dust. It's reading a story written in stone, a story about beginnings, about endings, about how close a planet can come to life, and how easily it can lose it. Somewhere in those layers of rock may be the quiet proof that life is not unique to Earth, or the equally haunting answer that it is. Either way, the moment we finally know will change how we see ourselves forever. And until those samples come home, until the microscopes focus, until the data speaks, the question remains, drifting between two worlds. Was Mars ever alive? Or are we still alone, watching a silent neighbor that almost made it?